start off with the definition of matter and what is matter. Matter is anything that has mass and takes up space. We can divide matter into two main categories, pure substances and mixtures. A pure substance, pure means that there's no impurities, there's nothing kind of mixed in with it. So a pure substance contains only one kind of matter, and it is uniform in composition. If you think about anybody that you know that wears a uniform, whether it be police officers or football players, they all wear the exact same thing. So they look the same when they're on a team or they work together. So uniform in composition means that it is going to look the same throughout. A mixture is a blend of two or more substances, and the composition may vary. So one part of it is going to look different from another part. I think about trail mix when I think about mixtures. And so if you go home from school and you're really hungry and you want a snack, and so you get some trail mix and you get two big whole handfuls of trail mix, the right hand that has trail mix in it is going to look different than the left hand. The composition is going to vary. Pure substances, as far as elements go, the elements are the simplest substance that we have, and elements are classified as one type of atom. They are all going to look the same. So some examples of elements. We have the periodic table of elements. Each block is made up of a different kind of atom. So here we have carbon, and then we have oxygen. Those are two different elements, and each is represented on a different block on the periodic table. Some other examples. Sulfur. We have each and every one of these particles, the green circles, look exactly the same. So sulfur is represented by the green circles. They all look the same. From the activity that we did, this is similar to the blue circles. They all look the same throughout. Oxygen, even though we have two atoms of oxygen that are together, it's only one type of atom. When we did our activity, we had the SQ2, where we had two squares together. This is an example of what SQ2 could look like in our world. Oxygen that we breathe in is found with two atoms of oxygen that are bonded together, but yet we only have one type of atom, so we classify it as an element. And for the purposes of what we are going to talk about at this point in time, for separation, we are going to say that they cannot be separated. Later on, we will talk about a few ways where elements can be separated, but for today, we're going to say that they cannot be separated. Not going to be separated by chemical or physical methods. Pure substances in the form of compounds, we have two or more different elements, and they're going to be held together by chemical bonds. That chemical bonds is important. They have specific names and formula that we'll learn about later on this year. how to write how to name them and how to write the formulas. For instance, whenever you have a compound, you are going to have two different capital letters in the formula. That's going to indicate that you have two different elements that are held together. Also notice there is no space between these two elements. So that's another way that we write the formula. The letters are together. There you have more than one capital, and there's no space or and sign. Something else about compounds is that the properties are different than the atoms alone. So hydrogen by itself is a gas. Oxygen by itself is a gas. A lot of times when we think about water, we think about liquid water. Sodium by itself is a metal. And chlorine by itself is a poisonous gas. But when we combine sodium and chlorine together, we make table salt, which we put on our French fries, and it makes our French fries pretty tasty. So the properties of compounds are different than the atoms alone, because we're not ingesting metal and a poisonous gas when we ingest salt on our French fries. We can separate them into atoms by breaking the chemical bonds, and we have to do this through a chemical reaction. And so then our other main category of matter is mixtures. We have two types of mixtures, a homogeneous and a heterogeneous mixture. So to start off with, a homogeneous mixture is going to be uniform in composition or evenly mixed. It's going to look the same throughout the mixture. An example of this is Kool-Aid. With Kool-Aid, to make it, you're going to take the sugar, the Kool-Aid mix, which is mainly sugar, some flavoring, which is made up of sugars, and some dyes, and you're going to mix that with water. Once all of the Kool-Aid mix is dissolved, it's going to be evenly mixed and look the same throughout. Since we are mixing it with water, it is going to be known as a solution. Another type of homogeneous mixture is alloys. If you play a brass instrument, brass is a mix of different metals. So brass is copper and zinc mixed together. Now notice I have two capital letters, but these are not together, and there is the space, the and sign here that divides these. So these are not chemically bonded together. They are mixed together. So that's the difference between a mixture and a compound when you're looking at the code or the formula for it. For homogeneous mixtures, we can separate them through physical methods, distillation and crystallization. So say you are making this pitcher of Kool-Aid to share with some friends, and after you're done, you have maybe like an inch or two left in the bottom. You've consumed all the rest of it. And then you leave it out for 3 or 4 days, and before your parents or whoever you live with says, hey, you really need to take care of that and clean it up. Well, over time, some of the water is going to evaporate from what's left. So maybe when you go to clean it up, the line is down here, just a little bit farther of where the liquid is. And you might find that in this region, there is some white or pink powder on the sides of the pitcher. Well, the water has evaporated and sugar crystals are going to be left behind, and they are kind of have that reddish pink color because of the dye within Kool-Aid. Heterogeneous mixtures are not uniform in composition. They are unevenly mixed. So when I was growing up, I liked when I got to have Lucky Charms for breakfast. And if you just go in and take a spoonful of Lucky Charms, and then you take another spoonful, each spoonful is not going to have the same composition because it is unevenly mixed. Now, yes, you could sit there and say, I want 1 marshmallow and 4 pieces of cereal in every spoonful, but it's going to take you a lot longer to eat it, and you're not randomly going into the bowl of cereal. Over here, I have some river water in a jar. And if you shake that, you can make it more evenly mixed. But there's water, there's dirt, there's sand, there's silt. So over time, it's going to separate. It is not evenly mixed. Each part of the river does not have the same amount of dirt and sand and silt. You can see this like the Platte River. You can see it with the sandbars and different things like that. Heterogeneous mixtures can be separated through physical methods, such as filtration. If you think about the gold rush and when they heard that there was gold out west, they went along the Oregon Trail and they would take some water and sand and dirt and rocks and a screen, and they'd shake it. They'd shake the water and they'd shake the smaller pieces of sand and dirt through the screen, filtering that out and leaving the bigger rocks and pieces of gold on their screen so that they could separate it. So those are the different types of matter that we are going to talk about today. On this page, there are some examples of matter in the you can place these at the bottom of your notes under elements, compounds, homogeneous or heterogeneous mixtures. Go ahead and pause the video and try to classify these on your own. Welcome back. Our first example is chromium. I see 1 capital letter. This is an element, which I'm going to abbreviate with an E. If you think about lotion, anytime you get some lotion out of the bottle, it's going to look evenly, it's going to look the same, which means it's evenly mixed, so it is homogeneous. Carbon monoxide, if we look at the code, we have 2 capital letters. We have no space, no and sign, so this is going to be a compound. Chocolate chip cookie. There's not going to be the same amount of chocolate chips in every single bite, so this is going to be a heterogeneous mixture. Methane, I have 2 capital letters, no space or and sign, so this is going to be a compound. Air is a mixture. Now we need to determine, is it a heterogeneous or a homogeneous mixture? Well, there are different percentages of carbon dioxide, oxygen, and nitrogen. So this is a heterogeneous mixture. Zinc chloride, gonna have 2 capital letters, so no space or and sign, so that is a compound. Chicken noodle soup is a mixture, and it is unevenly mixed, so this is also going to be a heterogeneous mixture. I don't like the celery in chicken noodle soup, so I can easily pick that out. Still, we have two capital letters, but we have the space and the and sign, so this is going to be a mixture. This is a homogeneous mixture. If you look at anything that is stainless steel, you'll see that it looks the same throughout, so it's a homogeneous mixture. For lead, we just have the one capital letter, so this is an element. Burrito, if you go to Chipotle or Qdoba, you can get yourself a burrito. Each bite is not going to have the same amount of rice and chicken and beans and salsa in it, so this is going to be a heterogeneous mixture. And then we have beryllium, one capital letter. This is an element. So that's it for today's notes. You need to take a look at the practice classifying matter, which should be letter D, I believe, on page 4. Thanks for stopping by. Have a great day.